think I'd like to appreciate the invitation from Bill Collins. He gave me this chance to present this very special topics, different completely from what we have listened in these 2 days. I know many of you are all experts or great scientists, but I'm not. I'm from mechanical engineering, and from some experiences, we found that excess energy can be obtained from a vapor compression system. That's a typical mechanical systems. So before I present the paper, I'd like to introduce some of my personal experience. Actually, I was a major in mechanical engineering for undergraduate and also graduate in both mechanical and chemical engineering in United States in 1976. Then I started my career in National Taiwan University, started for energy engineering after 1976. And before 1976, I was the scientist as you are here. I published my first paper in Nature, so I think I was a scientist. But since then, I was major in energy engineering, so I became engineer for 43 years until now. And I was looking for new energies, including high energy efficiency technology, like heat pumps, ejector technology, air conditioning, and refrigeration. All this related to what I'm going to present, the topics, and also LED lighting, and even a paper related to ejector is cited almost 600 times. It's #1 in International Journal of Refrigeration. The other interest I devoted myself was in renewable energy technology. Knowledge is another different story about solar photovoltaic, microgrid, and so on. One of the papers has been cited almost 500 times, which ranks top 25 in solar energy. So I'd like to introduce this so you understand what the next I was involved since last year. It's a new research interest, I call. Maybe I think this is the last for me before retirement. That will be in 2021. I call it a cavitation involved new energy technology. So the presentation today, I'm going to give a brief review on cavitation and what happens with cavitation with the low energy nuclear reactions, what happens in mechanical engineering society, not like you or scientists. And I like to share some interesting cases that I personally involved for mechanical system that can be COP greater than 1. It happens in commercial equipment. Then third, I'm going to give some commercial aspect. As I say, I'm engineer, not scientist. I'm more interested about how to commercialize the technology. Even I didn't know why it happens. Then I give some conclusions. So cavitation, I think a lot of people, all you scientists, are very familiar with the cavitation process. It's a kind of a vapor bubble formation, growth, and breakdown, collapse, and with compression shock waves, we call it implosion, that create a huge stress or huge impact. So it even damage the propeller in ship. So this picture are all taken by a university in Switzerland. And this picture shows how it happens. Vapor bubble formation grows and then breaks down. And then there's a water flow and then create a microjet. Create a microjet is a very high intense jet that damage the wall. So this phenomena may be related to something happened. It's been discovered about 80 years ago. It's called sonoluminescence. From formation of bubbles, growth, then quick sudden contraction, even implosion. Then you can see some light flashes. And this picture shows scientists do a lot of research, found that the bubble size can increase from 0 up to maybe 40 micrometer, and in 20 microseconds, then collapse here, about 20 microseconds, then create a light flash. So it's called sonoluminescence phenomena, and the temperature associated is estimated around 5,000 Kelvin. And if you look at the bubble dynamics, bubble mechanics, the pressure inside the small bubble, you can just do a very simple mechanical calculation about what the pressure inside the small bubble. If the bubble is in 1 millimeter diameter, nothing, the pressure is very low. If you down to 1 micrometer, then you got about 3 atmosphere. If you down to 1 nanometer, then the pressure inside almost 3,000 atmosphere. Such a huge high pressure inside the bubble can create some incredible phenomena that we didn't know yet. So if you look at the website, the internet, you can find many interesting phenomena found in the internet. A lot of people found that they can make a machine produce excess energy. It's called over-unit machine. And then this one is a machine made by Ukrainian scientists called Cavitation heat generator. It was a commercial product. It's been used in house heating. So simple, just use cavitation phenomena. And even in United States, some people made just cage with a lot of hole inside, just spin it with high speed, create high vortex flow. There's water inside. They claim that the excess heat can be generated, and the COP is 1.7. So before all that, I even did not believe that. I think I didn't see it and did not test, so I don't believe that before. And the other company you can find is in the internet called Cavitation Energy System Corporation, and they use a so-called hydrodynamic cavitation. They use a conventional automobile fuel injector in diesel engine to inject a high pressure water. It's up to 20,000 psi, very high pressure into the chamber. Then they claim that they can create a very micro bubbles. This is a simulation. Create a very teeny micro, I think even nano bubbles. And when it hit on the wall, then create a lot of interest phenomena. And maybe we still don't know how it happens, but the measurement tells you COP is about 5 at 388 degrees centigrade. So this the result is so exciting, and the company says they explain why it happens. They call thermolysis or plasma gases. I don't know what is that. I'm not a scientist now. So the company trying to develop a large power generator, 1 megawatt, something like that size. Okay, this is a commercial approach they are trying to do. But one question, if this result is true, why not it's been applied widely? If this is true, that means 1 kilowatt input, as this picture shows, generate 5 kilowatt heat. Then if you put into power generator with 30% efficiency electricity generation, you generate 1.5 kilowatt. Then you got net electrical output 0.5 kilowatt. But you have a lot of waste heat, about 3.5 kilowatt. You can use that for water desalination. Such kind of system should be very economic, feasible, and it can be widely accepted. But why not? So I have some doubt from common sense. First, the energy production cost like this machine maybe still very high. And also, the second, maybe COP is still not high enough. Maybe you need 10 or more. So I just give you a brief review on what happens in mechanical engineering field. Mechanical system can produce excess energy. And then I come to present two interesting cases of COP greater 1 in commercial equipment that I met myself personally in Taiwan. Two companies developed, one company developed pollution control equipment. They found this phenomena. And the second company, they call hydrogen-rich water making machine. They are selling water, not selling energy. Both found that COP is greater than 1. That was found by chance. The fourth case is company A. They develop pollution control equipment. They need micro bubbles for the pollution control chemical reaction with high temperature. And then they build a storage tank 1200 liter. Power input in total is about 38 kilowatts. Micro bubble generator like a ventilator tube. The water temperature is around 90 degrees, and the total heat output 93 kilowatt. That means COP 2.4. And the company come to me about 6 years ago, says to me that it's quite strange. They didn't know what about that, and they want the university to do more research and improve that. During that time, 6 years ago, I was so busy, so I just forget it. And until last year, I have some time before my retirement. This is a machine that built for commercial application. They sell a lot. And it is similar to Ukrainian machine called Cavitation heat generator. And the company sell a lot such kind of equipment, but they didn't know what happened. And also users didn't know also. They should not know. And then the second case is come from another company. Also happens several years ago, about 5 years ago too. They found that a vapor compression system can produce water with hydrogen rich. They just make water for sale. And use a vapor compression system. So I like to introduce something about what is vapor compression cycle. It's a principle of heat pump as we use the air conditioning system here. The refrigerant vapor is compressed by compressor, get a high temperature, high pressure vapor, then condensed, release the heat, and then becomes liquid refrigerant. And through expansion valve, expanded, absorb heat from outside. So this is a cycle we call vapor compression system. There's an evaporator absorb heat even from the room or from outside air. If absorbed heat from this room, this is air conditioning for cooling. If absorb heat from ambient air and use the heat to heat the room, is called heat pump. And today's technology, 1 kilowatt input to compressor, you can absorb about 5 kilowatt heat here. Then in total, you got 6 kilowatt output. So energy balance tells you output is equal to the sum of input of these two. And for the cooling, the COP is this. If the evaporator is not exist or 0 for heat transfer, then COP for heating should be less than 1 if there's a heat loss. But strange thing happens in this machine. The machine, as a compressor, got a high pressure, high temperature refrigerant vapor, then go through this I call steam generator. And the water coming here is cold water, 25 degrees. Then heat up to about 150 or 60 degrees, is steam, and then comes out. And there's no evaporator. So by energy conservation, thermodynamics, COP should be less than 1, but it is not. And what happens inside, what happened when after water comes in to the generator, it's been heated up in very teeny space. We call it a triple pipe exchanger. And the water go in this very teeny shape, and very long. The figure here is so simple. Actually, it's not so simple. The machine is like this figure. And the water is evaporated, and maybe cavitation occurs. And also a lot of strange things happen inside, and then produce heat more than what you input. And we didn't know how it happens. And we made another machine, but it did not work. Only some special combination of the design, it works. And this kind of machine can be repeated. So the company B produce machines, sell a lot of machines every year for the people who making called hydrogen-rich water. And the compressor is kind of reciprocating, very old-fashioned compressor. We use refrigerant 22. It's been phased out now. And the input 3 kilowatts, no evaporator, and the water making production rate is about 360 liters per day. So I met this company several months ago, and we have a cooperation. We try to measure what is COP. The company didn't care about the COP before, but I was so curious about it, so I just said, I'm going to measure it, what happens. And then I did a very simple experiment just by energy balance. The output steam just put into cold water and just doing energy balance calculation. And it shows the COP is over 1.5 to 1.3, depends on steam temperature. The higher steam temperature will lower the COP. It's a measured value. If the heat loss has been included, then the COP should be around 0.8, something like that. It's obvious, violate thermodynamics in all my life. So you cannot believe that, but we did a lot of tests for 2 months, run the test about 20 times. It happens, the same thing. And the machine can be run continuously for 1 more year until compressor break down. Usually compressor will break down about 2 years, like this. So something in common for machine with COP greater than 1. Maybe there's some I call a non-linear effect. So first, there's some cavitation phenomena involved because you hear noise when machine running, the water noise. And also there are some micro or even nano bubbles generated inside. And also there must have some intense implosion. So forget about the science. I didn't know what happens. Maybe you people can explain for me. But I forget that. I'm interested more about the business issue. For the company B, for this machine, I do some simple calculation for water business. The payback time less than 1 year. So that's why the company can survive. They make a machine doing good business in water business. So I like to point out some commercial aspect of vapor compression system like that. If we use that as a heat pump for space heating, not water making, then I compare with a CO2 heat pump I developed several years ago with a company. We developed it with a company. And the CO2 heat pump has been produced many in Japan. It's a commercial product. It's a kind of transcritical cycle with reasonable COP at low ambient temperature. But the system, because of the CO2, so it's run at transcritical cycle, so with high pressure. The pressure inside the system is higher than 100 bar. So the machine expensive and very low COP at temperature below minus 10 degrees. But with this machine, I mentioned the vapor compression system, and the COP is almost constant. Nothing to do with ambient temperature. It's not a heat pump to pump the heat from ambient air to the room. It generates some heat inside the machine. So if I do some comparison with two machines, CO2 heat pump, then in terms of the installation cost per kilowatt heating with minus 10 degree environment that's been in north latitude area, the cost is $6,000 because this machine costs about $100,000. We are on business. This is the real price. And with VCS linear heat pump, as I explained at comprehension B, it can run even at minus 30 degree ambient temperature. The cost about 2,000 to 1,000 per kilowatt. It's about 3 times or 4 times less than CO2 heat pump. This means even we didn't know what happened, but the commercial product can be go ahead. So conclusion, many machines has shown experimentally that the phenomenon of CO2 greater 1 exists. I didn't believe that several years ago, but now I believe that it happens. And it may be related to cavitation, nano bubbles, implosions, and possible linear effect. And the physics of CO2 greater than 1 still remains for the research, but commercial application has big potential to compete with existing CO2 heat pump. Thank you.
I think you're on.
Okay, for the water-based systems that are showing over unity COP, what are the pipes and interior metal surfaces made out of? Is it copper pipes or nickel-coated pipes or
Just copper pipe.
for all these water-based and steam-based systems?
It's a water pipe just used in condenser, like air conditioner. So the water content will have some copper ions inside.
Okay, thank you.
Okay.
Have you tested the copper pipes for any transmutations?
I didn't know.
Have you tested the copper pipes for any signs of damage or elemental shifts?
No.
Okay.
No.
Do you want to?
I think we take a long-term test, then see what happens.
Okay.
Yeah, I think I wanted to ask the same question to see if there is a surface analysis under the SEM microscope or EDX measurement to see the surface. That's all.
No, I hope we are doing later. Okay. We need some analysis for water.
I have a suggestion. I saw in your slides the thing with the injection pump from cars, I guess, right? Mm-hmm. Making also some COPs or cavitation, or what it was. My suggestion would be to use the high-speed jet that comes out of these pumps instead of cavitation. So
Sure.
I tend to believe that the jet alone that comes out of it, if it has a supersonic speed, will produce energy in the same way than the implosion jets do from the cavitation bubbles. And probably the efficiency of that is much higher, because here you accelerate only the liquid that comes out of these jets and nothing around it.
Actually, we are doing that, but I keep secret. Maybe next year I'm going to publish that. Maybe next year I can publish that before I file a patent. Okay.
Hi. In your vapor compression system back here, do you ever go out of the gas phase?
Yeah, inside it happens very interesting. It's water temperature goes up 150 degrees, maybe higher, then gradually decrease to 100 or 120. Depends on how you design the heat exchanger. Some of the machines, even the vapor inject out is in high pressure, about 150 degrees. It's dangerous jet output.
But do you ever go through the liquid phase?
Yeah, something inside is two-phase flow. Inside the heat exchanger is two-phase flow. But when you expand it to atmosphere, it will expand, and the quality of the steam, not 100%, depends how you operate, how you design it. So a lot of variations on such kind of machine depends on the conditions, control system you set, and also the water. Okay, I don't want to disclose too much about it. Okay. Something interesting inside, how you operate it. Yeah.
Yes. Have you measured the amount of deuterium in the water both before and after?
I have no idea about deuterium. And I'm going to ask some scientists to measure it for us.
Okay.
Have you considered using the wastewater in a hydroponic system, for instance, for growing vegetables?
You mean waste?
The wastewater, have you considered using it in a hydroponic system? There's work being done in Russia where they use corona discharge on water, and the seeds grow much healthier and faster. So you could maybe have a byproduct of healthy water.
Yeah, they claim that. Company claim that. So they sell the water to people. They drink. And some strange medical effect. But they need some clinical test long term. I don't believe that either.
Just to clarify, you see a continuous effects over a long time and no signs of something sporadic. That's almost too good to be true. Are there jumps, are there variations?
Yeah.
Are there variations in the performance of your systems, or they seem to provide a continuous output of a COP larger than 1?
Yeah. We do that because companies sell a lot to people. They run continuous. The longest lifetime is more than 1 or 2 years.
But without variations, large variations?
No. Continuous run, maybe 12 hours a day, something like that, for 2 years. They produce heat.
As a mechanism for generating cavitation without having to build your own equipment, maybe consider leasing yourself some time on a water jet cutter. You'll get higher pressure and higher velocity at lower per hour cost.
You mean use jet? But for vapor compression system, it's difficult to use water jet, combine with water jet, because water just go into the heat exchanger, then boil, cavitation, something happens inside. It's just back and forth, and you hear the noise, and sometimes very sharp.